Hey, what's up, everybody? Welcome to another session with Mr. Luna. So, we've been looking at solving inequalities with multiplication, division, subtraction, and addition. Now, we're going to be looking at solving multi-step inequalities using multiple operations. So, we're going to be using a combination of addition, subtraction, multiplication, and division. Now, when we're solving multi-step inequalities, it's the same process of solving multi-step equations. But with equations, you have one answer, whereas in inequalities, you have infinite number of solutions, and we can see that by a graph. So let's get into this first example and break it down and see how we can set up our inequality. Example 1. Erin has $52 to spend at the florist. She wants to buy a vase for $11.75 and several roses for $3.50 each. What are the possible number of roses Erin can buy? So the first thing we need to do is we need to determine what our constant term is and our variable term. Again, variable terms are going to have an unknown amount attached to it. That's why you use a variable. The constant term is just a one-time thing. It only happens once. So it looks like to me, the one thing that happens once is the purchase of a vase. That's a one-time charge. So that is our constant term. Our variable term is going to deal with our roses because she wants to buy several roses for $3.50 each, but she doesn't know how many. So that's where we can use our variable r. But then she wants to spend $52. Now she can't go over $52 because that's how much she has. So she can spend $52 or anything less than $52. So we can use a different sign. So we know that she can spend $52 and less. So our inequality is going to have to be less than or equal to $52. We know that she has $11.75 to spend on a vase. So that is my constant term. So it's $11.75 plus the amount for each rose, which is $3.50 multiplied by r. R represents the number of roses. $3.50 multiplied by r is the cost of roses. And the $11.75 is the vase. So now we have our inequality. Now we can solve using the inverse operations. So the purpose of solving inequality is we want to get our variable by itself. We want to isolate it. So we need to just get rid of everything that's attached to it. So the first thing I need to do is I need to change my inequality to an equation because I know that it's equal to. So let's rewrite it again to my equation, and it's simply you just change your inequality sign to an equal sign. It just helps, it's just easier to solve it this way because we know how to solve an equation, and it's a little bit cleaner. Now I can use my inverse operations to solve for r. I'm going to subtract $11.75 from this side. That means I must subtract it from the other side as well. It has to be balanced. Whatever you do to one side, you must do to the other. Let's just put my zeros here to make it easier for me. That equals 0. Now I just do $52 subtract $11.75. So all I have left now is $3.50 multiplied by r. R represents the number of roses, which is the unknown. That's what we're solving for. Equals $40.25. Since I have multiplication here, I need to use the inverse operation of division to isolate r. So I'm going to divide by $3.50 on both sides. This equals 1, so all I have left over there is r. So r equals, so $40.25 divided by $3.50. That's going to give me 11.5. So she can buy 11.5 flowers to equal $52. But can she buy 0.5 of a flower? No, she can't buy half a flower. So she can buy 11 flowers. And we solve our inequality. So R, the number of roses has to be less than or equal to 11. So R is less than or equal to 11. And this is going to meet the requirement of it being less than $52. So for this example, we looked at how to write our inequality. Then we changed our inequality to an equation so we could solve for R, which is our unknown amount, and then we wrote our solution. Let's look at another one. Example 2. We're going to practice writing our inequality again because we need to be able to understand how to formulate it. So know how to set it up. Members of the Science Club are selling coupon booklets for $17.95 as a fundraiser. They hope to exceed means more, the amount of money they raised last year. So they want to raise more money than they did last year. How many more coupon books for the variable B must they sell to achieve that goal? So we have a couple pieces of information. Last year they made $658.35. We know they want to exceed that amount. So that tells us what sign we're going to be using. It's more than, so it's going to be more than that. And then currently they have raised $498.75. So we need to be able to set up our inequality now using the information given to us. So whatever they made this year, plus whatever extra amount that they need, is going to tell us how much money they've raised. So we know that they made $498.75 currently. Sorry, let's backtrack. To set up our inequality, we need to know how much currently they made. So the current amount plus the cost of a booklet. And we're going to have to multiply the cost of the booklet by how many they sold, which is my variable B. And then compare that to last year's amount. And we know they want to exceed that amount, so it's going to be more than. So now we've written our inequality with words. Now we're going to apply the information that we know. We know that the current amount was $498.75. And I'm going to add the cost of each booklet, which was $17.95. So that's the cost of one booklet. But to find the cost of any number of booklets, I have to multiply it by B. And then we know that it has to be greater than $658.35. So now that we have our inequality with our values, now let's solve it. Let's change this to an equation to make it a little bit easier to solve. So 498.75 plus $17.95 multiplied by B equals $658.35. Now we're going to solve our equation using two steps. We have to isolate the variable, so I'm going to have to use the inverse operations. So my first inverse operation is I'm going to subtract 498.75 from both sides. So that left over, I have 1795 multiplied by b equals 169 and 60 cents. So I used the inverse operation of addition to cancel out my positives. Now I need to use division to solve for b, because the inverse operation of multiplication is division. That equals 1, so that cancels out. So all I have left with is b. So now I need to divide. $169.60 divided by $17.95. So that's going to give me this is 59. Let's backtrack. My math was off a little bit and I misread my calculator. It's $159.60. There we go. Just fix this. 159.6 divided by 17.95. There we go. So that's going to give me approximately 8.89 booklets. So obviously I can't sell 8.89 booklets, so that means they have to sell more than that to achieve their goal. So B, the number of booklets they have to sell is more than 8.89, and if we want to be technical, they need to sell more than 9 books. Okay, so again, solving multi-step inequalities, we wrote our inequality using the information given. Then we rewrote it as an equation, and then we used our inverse operations to isolate B, and that's what we solved for. So the number of booklets has to be more than 9. Okay, let's look at another one. Okay, so now we're just solving the inequality. Negative 10 subtract 9 halves multiplied by x is less than 80. It's the same process. I have to eliminate everything else that attached to the x so I can isolate it to get by itself. So let's rewrite my inequality as an equation. So I have negative 10 subtract 9 halves multiplied by x equals 80. I'm subtracting 10, so I need to add 10 to both sides. That cancels out. So now I have left 9 halves x equals 90. It's a negative though, don't forget that, because we have a negative sign. Now when we looked at solving equations with 2 steps, when you divide by a negative, that's going to change the sign of our inequality. So it's going to flip it. And we can test that as to why that will work. But the first thing I need to do is I need to multiply my fraction by the reciprocal so it equals 1. Then I must do it on the other side as well. Because negative 2 multiplied by 9 sorry, negative multiplied by negative is positive, so 18 over 18, that just equals 1. So that's why it cancels out. 90 multiplied by negative 2 is negative 180. And then this is just a 1 underneath it, so this is 9. We don't need the 18 over 18 because it equals 1, so all we left is just x. So x equals negative 180 over 9. We know that 9 is a factor of negative 180, so just do the division. So x equals negative 20. And since our sign originally was less than, since we multiplied by a negative, it's going to be switched. So x is actually greater than negative 20. And if you want to prove that, if you want to check it, here you need to use a number line. So here's 0, here's negative 20, and here's positive 20. So when it says x is greater than negative 20, that means anything that is closer to 0 on the left side or farther from 0 on the right side. It's going to be an open circle because it's not set to equal to. So if we want to test that if any number greater than negative 20 is true, just test a value. So I'm going to test 0 because that's the easiest one to test. So I'm going to plug in 0 into my original equation. So negative 10, subtract 9 over 2. 0 is my x value. So plug that in, equals 80. When we multiply, not my equation, my inequality. My original inequality was set to less than. So negative 9 halves multiplied by 0 is just 0. So all I have left with is negative 10 is less than 80. That checks out. That's good. So when x equals 0, that is also true because we just proved that negative 10 is less than 80. So we know that if 0 is true, then it's going the opposite direction. So x is definitely have to be greater than negative 20. Okay, so now there's just two steps equations where we had to either add or subtract first, then multiply or divide. Now we're going to be looking at using our properties that we've been practicing and combining everything at once. So we're going to solve this inequality, and then we are going to graph the inequality to show all possible solutions. So here's my inequality. It says negative 3 multiplied by x plus 4 plus 3 is greater than or equal to 9. So again, this is greater than or equal to this line underneath. That's going to tell me that it's an open circle. Closed circle. The greater than or equal to or less than or equal to, that indicates that whatever the solution is, it's included in the answer set. So it's going to be open. Sorry, closed. Closed circle. First I need to do is I need to rewrite this as an equation to make it easier for me to solve. Equals 9. Now I have a coefficient, which is negative 3, outside of parentheses. We've talked about that if you have a coefficient on the outside of your parentheses, you can use the distributive property. So I'm going to multiply negative 3 by each term inside. So negative 3 multiplied by x gives me negative 3x. Negative 3 multiplied by positive 4 gives me negative 12. And then plus 3 equals 9. So now I have negative 3x plus negative 12 plus 3 equals 9. Now I need to combine like terms. you can only combine constant terms and you can only combine variable terms. So in this case, I have two constant terms, negative 12 and positive 3. So I'm going to add those together. So now I have negative 3x, negative 12 plus 3. That is going to give me negative 9. Negative 12 is farther from 0, so the difference is going to be a negative amount. Okay, now this looks familiar. I have two steps. I'm going to add 9 to both sides because I want to isolate everything attached to the variable. So that cancels out. So all I have left with now is negative 3x equals 18. Use my inverse operation, divide by negative 3, divide by negative 3. This equals 1, so that cancels out. So now all I have left with is x equals negative 6. It's negative 6 because a positive divided by a negative is a negative. Again, we divided by a negative right here. We divided a negative, so that means our inequality sign has to change. So this original inequality sign has to change. So x can be less than or equal to negative 6. And let's test that. So x has to be less than, so that means that has to be more negative than negative 6. Here's my number line. Here's 0, here's negative 6, and here's positive 6. We know that's a closed circle because our inequality sign was more than, or was more than or equal to, so it's a closed circle. Now to test which way it's going to go, we're going to test a value. And I like to test 0 because multiplying and dividing by 0 is really easy. So we're going to plug that into our original inequality. So I have negative 3, x plus 4 plus 3 is greater than or equal to 9. So now I'm just going to plug in 0 into the x spot. Negative 3, 0 plus 4 plus 3 is greater than or equal to 9. Now to solve it. Negative 3, 0 plus 4 is just 4, plus 3 is greater than or equal to 9. Negative 3 multiplied by 4 is negative 12. Negative 12 plus 3 is greater than or equal to 9. Negative 12 plus 3 is negative 9. Negative 9 is greater than or equal to 9. That does not work out, so that's not true. So if 0 is not a solution, that means it has to go the opposite direction. And so that means your solutions can be negative 6 or anything less, which makes this true. All right, so that's solving inequalities with multiple steps. In this case, we added the distributive property. This should help you with the last two lessons for this week. Hopefully these have been helping you. If you have any questions, please email me or contact me. All right, peace out. Hope this helps.